From space, our planet is covered in strange shapes and patterns that don't look real at first glance. So today, I'm counting down 15 of the most unusual shapes seen from space. Starting with number 15, the upheaval dome. Well, the upheaval dome is one of the most visually unusual landforms in the United States, notable for its nearly circular shape and the way its internal layers twist around a central point. It's located in the Canyonlands National Park in southeastern Utah. The structure's about 5 kilometers, that's 3 miles across, and from above, satellites show a pattern, a raised outer rim with progressively deformed and uplifted rock layers towards the center. This arrangement makes the formation stand out against the surrounding flat-lying sandstone. The origin of the upheaval dome has been studied for decades. 2 main explanations exist. The current leading interpretation, supported by peer-reviewed studies and field evidence, is that it's the eroded remnant of a meteorite impact structure. Geologists do point to the presence of shock quartz, a form of quartz that contains microscopic deformation features that only form under extremely high pressures, like those generated during an impact. These shock features were documented in the early 2000s by researchers who examined the rock samples from the central uplift area. Now, the second hypothesis, which had been discussed for many years before the discovery of shocked quartz, is that the structure formed through salt diapirism, a process where buried salt deposits rise upwards through overlying rock layers. Salt domes are well known in the Gulf Coast regions and parts of the Middle East, but they're less common here in southeastern Utah. Well, regardless of the precise formation mechanism, the dome's appearance from above is clear and distinctive. That inward tilting pattern is characteristic of a structural dome, but is steeper and more sharply defined than typical geologic domes. On the ground, the dome is kind of difficult to interpret because of its scale and the ruggedness of the terrain around it. The full circular outline only really becomes apparent when viewed from above. Today, visitors can observe the formation from 2 officially maintained overlooks, but the complete pattern is something only visible from above. This site continues to be studied, and while the impact origin is strongly supported, research remains ongoing to classify the detailed sequence of its formation. Number 14. The Great Bend of the Nile. The Great Bend of the Nile River is one of the most recognizable natural curves on the Earth. It forms a massive S-shaped arc as the Nile River flows through northern Sudan. The bend mainly happens in the region between the towns of Dongola and Abu Hamed, where the river loops westward before turning sharply back east towards Egypt. But we all know the Nile is known for having one of the most stable courses of any major river in the world. But this particular section shows a dramatic deviation from a straight path. The primary cause of the bend is geologic, of course. The river follows zones of weaker bedrock created by ancient fault lines and fractures in the Nubian sandstone. The contrast from above is especially striking. The irrigated floodplain along the bend forms this narrow green ribbon. It's often only a few kilometers wide, surrounded by huge expanses of desert. In satellite images, the bend almost looks like a deliberate stroke that was just painted onto the landscape. The bend includes some of the Nile's steepest and rugged canyon sections, particularly near the Fourth Cataract. Now, historically, these cataracts made travel and trade difficult. Though modern dams and reservoirs have altered the area of parts of the bend, still though, the river's basic geography remains unchanged. It is a common point of reference for astronaut photography, where its bright greens and large curvature are easy to identify even from the ISS. From above, the Great Bend of the Nile stands out as one of the most prominent natural shapes on the Earth. Number 13. The Etosha Pan. The Etosha Pan is one of the largest and distinctive salt pans on the planet, covering roughly 4,700 square kilometers inside Etosha National Park in northern Namibia. From above, it looks like an enormous, irregular white shape surrounded by darker savanna grasslands. This brightness and unusual outline make it immediately recognizable in imagery. The pan is so reflective that it can even be identified from low-resolution orbiting sensors. Evidence from sediment cores here and shoreline deposits show that around 2 to 10 million years ago, a large inland lake occupied the basin, fed by rivers flowing from higher ground to the northeast. Over time, uplift and river course changes redirected water away from the basin, causing the lake to shrink and eventually evaporate. Today, the pan is dry for most of the year, though seasonal rains temporarily create shallow water pools. Its extremely flat topography means that even a few millimeters of water here can spread across a wide area, producing a reflective surface that appears silver or pale blue in satellite photographs. And while the central area is largely barren, the surrounding grasslands do support some of southern Africa's largest wildlife populations. Flamingos also breed in the pan during particularly wet years when water depth is suitable, and these events are regular and depend entirely on rainfall. Some satellite images capture herds of elephants, zebras, or springbok that are clustered around the pan's seasonal water edges. And although the pan is sometimes compared to the other large salt flats like the Salar de Uyuni in Bolivia, it does differ in both origin and appearance. From above, the Etosha Pan stands out as one of Africa's most dramatic natural shapes. Number 12. The Kimberley Diamond Mine. Often referred to as the Big Hole, that's a mom joke in there somewhere, the Kimberley Diamond Mine is one of the world's most recognizable human-made excavations. It's located in the city of Kimberley in South Africa's Northern Cape Province. It's circular when viewed from above, and it creates a sharp contrast with the surrounding land. Mining at the site began in the late 19th century, during the major diamond rush that attracted thousands of prospectors. Between 1871 and 1914, miners extracted the site almost entirely by using hand picks, shovels, and basic tools. Over those 4 decades, they removed an estimated 22 million tons of earth and yielded roughly 3 tons of diamonds. Its size measures roughly 460 meters across at its widest and descends about 240 meters down. But after the mining ceased, the groundwater gradually filled the lower section, which created the dark water surface seen in modern imagery. And unlike irregular open-pit mines that follow twisting ore bodies, the Kimberley pipe was roughly circular in the planned view, allowing the miners to dig a near-round perimeter. The kimberlite pipe beneath the Big Hole is part of a much broader distribution of volcanic conduits that are responsible for bringing deep-origin diamonds to the surface, and the visual clarity of the pit makes it an excellent example of a vertical pipe structure. However, only the uppermost sections of the pipe are visible today. Deeper structures lie beneath the water-filled pit. Today, the site is preserved as part of the Kimberley Mine Museum, which includes exhibits on diamond geology and the history of the mining industry in South Africa. The mine itself is stable, and structural analyses indicate no imminent risk of collapse. The water level fluctuates, though, due to rainfall and evaporation, but doesn't affect the overall appearance from above. Number 11. The Voisey's Bay Mine Spiral Roads. The Voisey's Bay Mine in Labrador, Canada, is one of the most visually unusual mining sites seen from above because of its network of spiral and looping service roads. Now, unlike the typical terraced patterns you see in most open-pit mines, this one's road layouts form curving, almost snail shell-like shapes that stand out clearly in satellite imagery. Now, Voisey Bay is a major nickel, copper, and cobalt operation. It's located along the northeastern coast of Labrador. The terrain around the mine consists of rolling hills, exposed bedrock, and glacially carved depressions. This led to curved ramps and looping access routes that twist around pits and processing areas, and from above, these routes create a series of arcs and spirals. Mining here began in the 1990s after the discovery of high-grade nickel sulfide deposits, and the site became one of the most important mineral finds in Canada's recent history. Unlike many mines, though, in flatter regions, this one had to be designed in a way that accommodated permafrost, marshes, and rocky outcrops. Those conditions limited straight-line road construction, and they contributed to the winding geometric pattern that's still visible. This unusual geometry, though, has attracted attention in remote sensing studies. Researchers analyzing land use in the northern environments sometimes use this as an example of how industrial activity will modify Arctic and subarctic terrain. These spiral patterns are not symbolic or historically meaningful, they're simply reflecting the most efficient paths for machinery hauling ore and waste rock. Even so, the surface features, though, remain visible in modern imagery, and the spiral roads are all still present around the waste ponds, maintenance areas, and processing facilities. Number 10. Mount Taranaki's Circular Forest Boundary. Mount Taranaki in New Zealand. It's one of the most iconic features visible from above because of that perfectly circular boundary that surrounds it. Now, the circle is not a geological formation. It's the result of land management decisions that created an unusually sharp transition between dense forest and cleared farmland. The mountain sits at the edge of Edgemont National Park, a protected reserve established in 1900 to conserve native forests. The boundary was drawn as a simple radius around the peak, producing a near-perfect circle that's roughly 19 kilometers across. From above, you can see the contrast is pretty dramatic. Inside the circle, the land is covered with dark green, temperate rainforest, which is characteristic of the region. Outside the boundary, the landscape shifts immediately to a lighter-colored agricultural land that's dominated by pastures, dairy farms, and rural settlements. The mountain itself rises to about 2,500 meters and is a symmetrical stratovolcano. Its nearly conical shape complements the circular reserve around it, making the entire feature one of the clearest geometric patterns in global satellite datasets. When the government created Edgemont National Park, surveying was done with basic instruments compared to today's standards. The simplest method to establish a protected zone was to just offset the boundary an equal distance from the volcanic summit, which resulted in this circle. There's no gradual transition from the grasslands and livestock operations, which adds to the clarity of the shape here. Researchers studying habitat fragmentation, though, often cite Taranaki as an example of how conservation areas can maintain the ecosystem, even when surrounded by heavily altered landscapes. And while the volcano itself is dormant, it's not considered extinct. Geological records show an eruption history spanning tens of thousands of years, with the most recent activity happening in the mid-1700s. However, this doesn't affect the visibility of the boundary, which remains stable. Number 9. Vierfjall Crater. So I know I can't pronounce this one in the original Icelandic, so I'm gonna let my American mouth say Hverfjall, located in northern Iceland near Lake Mývatn. It's one of the most visually distinctive volcanic craters in the world. When viewed from above, it appears as a nearly perfect dark circle set against a lighter surrounding landscape. Geologists classify it as a tephra cone. It's also known as an explosion crater, formed during a violent eruption about 2,500 to 2,900 years ago. The crater measures about 1 kilometer in diameter and it rises up steeply from the surrounding lava fields. This bowl-shaped interior is also highly regular. The geometric clarity here is rare, as many volcanic craters become distorted by later eruptions. From above, though, the crater looks almost like a giant black disk. The rim forms a sharp, continuous ring that contrasts with the paler ground, and the interior appears darker because it's composed of fine-grained volcanic materials like ash and scoria. In winter, though, when snow covers the surrounding landscape but melts quickly on the darker volcanic slope, the crater can become even more pronounced. Geologists are continuing to study it to understand Iceland's volcanic history, and it's frequently referenced in scientific literature because it is a textbook example of a tephra ring. This crater's symmetrical structure is visible in all major satellite mapping platforms, too. Human activity is minimal around it. A few hiking trails lead to the rim, but strict conservation rules prohibit any descending into the crater, which helps preserve its structure. And although Iceland has many volcanic features, this one stands out because of its symmetry and its clarity. Unlike calderas that can span tens of kilometers or complex lava fields with irregular shapes, this compact size and perfect circular outline makes it easy to identify from orbit. Number 8. Pivot irrigation circles. The pivot irrigation circles in Kansas in the United States are among the most recognizable geometric patterns on Earth. Seen from space, they appear as thousands of perfectly round green or brown disks that are spread across the state's agricultural regions. Each circle is typically about 400 to 800 meters in diameter, though the sizes do vary depending on the land ownership and the system design. This uniformity and scale of the circles do create a distinctive mosaic that's easily visible even in low-resolution imagery. The circular shapes are the result from a center pivot irrigation system, which is a farming technique that was invented in the U.S. in the mid-20th century and widely adopted in Kansas beginning in the 1960s and 70s. In this system, long pipe equipped with sprinklers rotates around a fixed central point, watering crops in a circular pattern. This rotation is powered by electric or diesel motors, and the system moves slowly across the field, delivering a uniform amount of water. When adjacent fields use a different crop type or maybe irrigation schedule, the resulting color contrasts makes the circles even more pronounced. The straight-line property boundaries between the farms create partial circles along the edges, which adds a variety to this overall pattern. The semi-arid western regions of Kansas rely heavily on irrigation because rainfall alone can't sustain large-scale agriculture. Much of the water is used in pivot systems here is drawn from the Ogallala Aquifer, a huge underground water source that spans several states. The uniform geometry, though, does make them ideal for calibrating satellite instruments and analyzing land use changes. Variations in color, brightness, or texture within a circle can reveal changes in irrigation patterns, soil moisture, or plant stress. And although center pivot irrigation exists all over the world, Kansas does stand out for the density of the circles and their uniform size. The regularity of the farmland grid here enhances the effect, and it makes the state's agricultural regions one of the clearest examples of large-scale geometric land modification that's visible from space. Moving on to number 7, the Chott el Djerid pink salt shapes. The Chott el Djerid, located in southern Tunisia, it's one of the largest salt flats in the Sahara, covers about 5,000 square kilometers, and from above the region displays an array of bright colors and unusual shapes. There are mineral deposits that create patches of pink, orange, red, and white across the surface, and these variations result from natural interactions between salt, minerals, and shallow water. The entire basin is a closed drainage system, meaning that water entering doesn't flow out to the sea. Instead, rainfall and occasional runoff from surrounding mountains become trapped in the depression. And during the hot season, which dominates most of the year, evaporation concentrates minerals, leaving behind these colorful crusts. Sodium chloride creates white zones, while iron-rich or algal-influenced deposits often produce shades of pink or red. The exact distribution, though, of colors changes over time due to the weather, the water depth, and mineral content. In the shapes visible from above, you can see cracks that form geometric patterns in the drying salt crust, producing polygons that can stretch for kilometers. These polygon textures appear bright and reflective in these satellite photos, which creates high contrast with the surrounding beige desert. In wetter years, temporary shallow lakes will form, displaying gradients from pale pink to deep red, depending on the concentration levels. And of course, the climate here in this region plays a major role in shaping all the appearances. Summer temperatures often exceed about 45 degrees Celsius, that's 113 Fahrenheit, and it causes intense evaporation and rapid crystallization. During winter, occasional rainfall does spread thin sheets of water across the pan, which dissolves the surface salt. And from a remote sensing perspective, this area is frequently used as a calibration site for satellite instruments, similar to other large, bright salt flats around the world. Researchers are studying mineral distribution here and desertification patterns that regularly analyze the satellite data. With its amazing colors and irregular shapes, it does stand out as one of the Sahara's most distinctive natural patterns. Number 6. The Mono Lake Islands. Mono Lake is located in eastern California near the Nevada border. It's a large alkaline lake known for its chemistry and islands. And from above, 2 of these islands, Paoha Island and Nejit Island, form a pair of round or near-round shapes that stand out clearly. The geometry makes them appear kind of like twin circles, despite being formed through independent process rather than any deliberate pattern. Now, Nejit Island is the smaller and darker of the 2. This is a volcanic cone composed primarily of basaltic lava and pyroclastic material. The rounded shape is the result of eruptive activity that built the slopes around a central vent. Nejit's circular form is well preserved because the island has experienced little erosion compared to older structures. Paoha Island is the larger of the 2, has a different origin. It formed when volcanic and hydrothermal activity uplifted lakebed sediments less than 350 years ago. Unlike Nejit, Paoha is pale, has light-colored surfaces due to the composition of sediments mixed in with volcanic debris. The twin circular outlines of Paoha and Nejit remain clear regardless of water level changes here. When the lake levels rise or fall, the shorelines shift slightly, but the island's overall symmetry stays intact. The location near the center of the lake further enhances that circular illusion as the surrounding water forms a natural frame. Mono Lake has been extensively studied. The lake hosts some brine shrimp and alkali flies that support large populations of migratory birds, particularly gulls. And these ecological details don't affect the visual appearance of the islands, but they contribute to the scientific significance of this place. Today, both islands remain stable, and their shapes continue to stand out in modern imagery. And while many lakes worldwide contain islands with irregular outlines, few have 2 nearly circular islands positioned so closely together. Number 5. The Okavango Delta Fan. The Okavango Delta in northern Botswana is one of the most recognizable shapes on the planet, especially when viewed from space. This broad triangular fan, sometimes described as a hand, a flower, or a network, covers roughly 15,000 square kilometers in typical flood years. Now, unlike most river deltas, which meet an ocean or a sea, the Okavango spreads out across the Kalahari Basin, forming the world's largest inland delta. This fan shape emerges from the way the Okavango River splits into countless distributary channels after crossing the border from Namibia to Botswana. Once it reaches the flat sandy floor of the Kalahari, the river slows down, causing water to fan out across the landscape. The result is this complex mosaic of wetlands, lagoons, islands, and floodplains, arranged in branching patterns that radiate outward. Of course, the shape does change each year slightly depending on regional rainfall and inflow, and the contrast, though, between Okavango's green floodplains and the surrounding tan areas of the savanna makes the delta visible from way up high. In dry years, edges retreat but still maintain triangular outlines, and in wetter years, the fan expands, filling depressions and temporarily enlarging lagoons. Geologically speaking, this delta sits on a series of fault lines that do tilt the land slightly from northwest to southeast, and that tilt does influence the direction of water spreading and helps maintain the geometry of the fan. Because the delta doesn't drain into the sea, water does eventually evaporate or infiltrate into the desert sands, and that contributes to the formation of mineral-rich areas, including salt pans and bare patches that stand out too. These internal contrasts adds texture to the overall triangular form and reveal the complexity of this hydrological system. And from above, it is a rare example of a natural fan structure that's formed entirely by water just interacting with a flat desert. Number 4. The Unyanga Lakes. The Unyanga Lakes, located in northeastern Chad, form one of the most unusual lake systems in the Sahara. Seen from above, the lakes appear like a string of elongated blue and green shapes arranged in narrow chains, surrounded by orange-red sand dunes. There are two primary groups, Kebir in the north and Sarir to the southeast. Together they contain more than a dozen lakes, fed not by rainfall, which is extremely low in this region, but by ancient groundwater stored in deep aquifers. Today, the lake does persist because groundwater flows upwards through the sandstone, maintaining water levels even in an environment where evaporation far exceeds the precipitation. Now, the shapes of the lakes are distinctive. Many are long and narrow, some stretching kilometers while remaining only a few hundred meters wide. This alignment follows wind dune ridges, which act as natural barriers. As the dunes migrated over time, they just trapped the water in the depressions, forcing the lakes into these elongated forms. Some appear deep blue, and that's caused by the depth and clarity of the water, while others have lighter green shades caused by sediments or algae. These differences can be seen clearly in imagery. Vegetation, though sparse, forms narrow belts of reeds along the lake shores. One of the most prominent lakes is Lake Yohan. It's among the deepest in the system and has been the subject of significant paleoclimate research. Sediment cores taken here from the lake bottom contain continuous records of environmental conditions dating back at least 6,000 years. These records confirm the presence of what's known as a Green Sahara period, when the whole region supported lakes, grasslands, and wildlife that's now impossible under current conditions. In Sarir, groups of smaller lakes do lie closer together, that's separated by thin dune ridges, and that configuration is photogenic from orbit. It's widely used in scientific publications and on desert hydrology. The region is sparsely populated and human activity is limited, but from space, the Unyanga Lakes look like a rare and distinctive pattern, narrow, elongated water bodies aligned like beads on the desert sand. Number 3. The Al-Wusta Oval Sand Ridge. The Al-Wusta region of central Saudi Arabia contains a natural sand formation that shows up clearly in satellite imagery due to this unusual, elongated oval shape. Found within the broader empty quarter adjacent desert environment, this ridge stands out because its line forms a smooth, continuous ellipse across a landscape otherwise dominated by irregular dunes. Now, the oval ridge is composed primarily of Aeolian sand, which is shaped by prevailing winds that sweep across the Arabian interior. Unlike crescent-shaped Barchan dunes or star dunes common elsewhere in the region, the Al-Wusta Ridge maintains a stable, enclosed shape that doesn't break into multiple horns or branching forms. The dimensions of the ridge is pretty big, several kilometers long and roughly a kilometer wide. It allows the shape to be fully captured even in medium-resolution imagery. This region is known for its important archaeological discoveries, including ancient human and animal fossils preserved in former lake beds. The ridge itself, though, doesn't mark a former lake, but the position relative to nearby paleo lakes has been noted in some environmental surveys. But from above, it resembles a large track or imprint with smooth curves unlike most dune shapes. It's not man-made, and there's no evidence of historical modification or boundary alignment. Its geometry is purely the result of wind interacting with topographic features. And while similar oval dunes exist elsewhere on the Arabian Peninsula, this one is among the clearest and most symmetrical. From above, the Al Wusta Oval Ridge stands out. It's a rare example of a natural dune structure shaped into a clean geometric form, an elongated sand ellipse that's visible in the heart of Saudi Arabia's desert interior. Number 2. The Ait Ben Haddou Geometric Fields. Located just west of the historic area of Ait Ben Haddou in southern Morocco, a series of agricultural plots create amazing patterns that are visible in satellite imagery. Their layout, rectangular, trapezoidal, and sharply angled, produces this patchwork that appears grid-like when viewed from above. Each agricultural plot was shaped based on irrigation channels, property boundaries, and the natural contours of the valley floor, and over time farmers built a network of small canals and earthen walls that direct water from the river into the fields, and that's resulted in patterns that appear clearly organized. While many river valleys around the world show this kind of agricultural development, these fields stand out because of the sharp border between the cultivated land and the barren slopes. The sudden shift to bright green fields shows the geometric boundaries and makes them highly visible from space. The historical Czar of Ait Ben Haddou is a UNESCO World Heritage Site, and it sits above the field on a hill. While the Czar itself forms irregular earthen structures, the agricultural zone below contrasts with the precise man-made shapes. That juxtaposition is pretty striking, ancient organic architecture overlooking modern systems. But the field shifts slightly over time as some plots are expanded, abandoned, or reconfigured. Seasonal growth cycles also affect their appearance. In the early spring and summer, they show bright greens. After harvest, they often appear tan or gray, but the geometry remains. Multiple satellite missions, including Landsat and the Sentinel programs, have documented this region for decades. The clarity of the shapes make them useful for land use studies and remote sensing classification exercises. Number 1. The Manicouagan Reservoir Ring. Quebec, Canada, the Manicouagan Reservoir. It's one of the most recognizable circular landforms on Earth. As seen from above, it appears like a nearly perfect ring of water surrounding a central island, creating a shape so distinct that it is often used as a reference point for satellite imaging. The structure spans about 70 kilometers in diameter, makes it one of the largest and clearest known impact crater lakes on the planet. Now, the reservoir fills the impact crater formed about 200 million years ago during the late Triassic period. Geological studies showed that a meteorite struck the region with enough force to excavate a multi-ringed basin in the surrounding crystalline bedrock. Over millions of years, erosion softened the crater's original features, but the circular outline remains preserved. Today, the most visible remnant, of course, is the annular lake, an almost unbroken ring of water that encircles René-Lavoisier Island, the central uplift produced when the Earth's crust rebounded after the impact. The island is one of the largest lake islands in the world, and itself was shaped by erosion, acting on the uplifted rock. In the 1960s, the construction of the Daniel Johnson Dam and other infrastructure along the Manicouagan River raised the water levels, which enhanced the visibility and continuity of the circular lake. The dam didn't create the ring shape, but it did fill in low-lying sections, making the circle more visually complete. Remote sensing experts, of course, often reference the Manicouagan Reservoir when identifying circular features on Earth, because it represents a well-preserved and easily verifiable impact structure. High-resolution satellite data from NASA, the ESA, and commercial platforms consistently capture the ring and its interior features. From a satellite perspective, the Manicouagan Reservoir is one of Earth's clearest large-scale circles, a natural impact scar transformed over time into a striking annular lake. Its size, symmetry, and stability across millions of years makes it one of the coolest distinctive shapes seen from above.